Hello folks, this is Shraddha Bharti and I welcome you all to yet another lecture on bending moment diagram. And in this lecture, we are going to solve a question which has been asked in the ESE examination in the year 1996 for 8 marks. So what is the question? A frame is given and you have to draw the bending moment diagram for this frame. So look carefully, a frame is given with an internal hinge at point C and there is a load of 16 tons acting at point D, and the distance between various points are given. Okay, without further discussion, let's start the question. So what shall be the approach? Our first step is to find the reactions at point A and point F. We have to first find out the reactions at these points. Okay, let's see. There is a vertical load acting in the downward direction. So to counter this load, there must be a reaction at A and reaction at F, which must be in the upward direction, right? Also from this, we know that RA plus RF, because they both are acting in the upward direction, must be equals to 16. I'm not writing tons. This is our equation number 1. A horizontal reaction must also act here. That is, let me write horizontal at A and horizontal at F. Since there is no load acting in the horizontal direction, these two horizontal reactions must counter each other. Okay, so here we know that HA must be is equals to HF. They must be equal in magnitude and opposite in direction, since there is no external load acting in the entire frame. So this is our equation number 2. But we see that there are 4 unknowns, that is RA, RF, HA and HF, and we have to find all those. But we have only 2 equations present over here. So how will we get another 2 equations required for solving these? So next step, what we are going to do is that very cleverly, we see that there is a point C over here, and we know that there is point C is the internal hinge and the moment at point C must be equals to 0. So we'll take the moment first from the frame of this part, that is ABC. From the left part of the hinge, we'll take the moment about point C. Let's do that first. HA will try to rotate the frame. This HA will try to rotate the frame in the anti-clockwise direction about point C. So it is causing an anti-clockwise moment. Okay, I hope there is no problem taking the moment. If someone is still facing the problem, please let me know in the comment section and I'll create another video for this one. So HA into, what is the vertical distance between A and C? The distance between A and C is this distance, and that is 4 meters. So HA into 4, this is anti-clockwise moment, must be countered by this RA. RA is trying to rotate the frame in the clockwise direction about point C. So we'll write RA into, what is the distance between RA and C? So the distance between RA and C is this one, which is 4 meters, nothing but 4 meters. So RA into 4 meters. So from this we get HA must be is equals to RA. So these two are same thing. So this is another equation number 3. Now we'll try to form another equation from the right hand side of the beam. We'll try to take the moment from the right side of the beam. Let's do that. So we'll consider this portion of the beam here and see that 16 ton is trying to rotate the frame in the clockwise direction, right? So we'll write 16 into, what is the distance between 16 load and point C? It is 2 meters, right? This is 2 meters. 16 into 2 meters. So I'll write a plus sign for another clockwise moment. HF is producing another clockwise moment. It is trying to rotate the frame in the clockwise direction about point C. So HF into, how much is the distance? Distance between HF and point C is 4 meters. Here it is given 4 meters. Must be equals to RF is trying to rotate the frame in the anti-clockwise direction about point C. So all anti-clockwise together. So RF into, what is the distance between RF and C? So it is 2 plus 2, that is 4 meter. So solving this, we can write, I'll make it simpler. 4RF is equals to 4HF plus 16 twos is 32. Or we can write RF is equals to HF plus 8, right? So these are four equations we have got. So now there are four equations and also there are four unknowns. It's very easy to solve them, right? So this was the first step. Okay, so what we will do, we'll put everything in equation number 1. RF is equals to HF plus 8, but from equation number 2 we know that HF is equals to HA, so we can also write it as HA plus 8. So we'll put HA plus 8 instead of RF in equation number 1. We also know that RA is equals to HA from equation number 2. So instead of RA, I am writing HA, and instead of RF, I am writing HF plus 8, which is nothing but HA plus 8. So I am writing HA plus 8 over here. It is 16. From this 2 HA plus 8 will give me 16, or HA is equals to 8 minus 8 by 2, that is 4. So once we got this HA as 4, so this HA is 4, that means HF is also 4 from equation number 2. So what are the values which we are getting? HA as 4, HF as again 4 from equation number 2, and RA again as 4 because RA is equals to HA from equation number 3. RA is again 4, and what is RF? It is 12 from equation number 1. RA plus RF is 16. So RF must be equals to 12, right? So these are the values which we got from the equations. I hope this much is clear for everybody. Now let's proceed. Our next step is to analyze the beam. So we'll be starting with part AB. Now here is the reference. We will be starting with part AB. Now for part AB, we know that HA is how much? HA is 4. RA is how much? RA is also 4. So we'll be starting from this point. So I am putting here HA as 4, and then there is an upward reaction RA, which is also 4 tons, right? And this is point A and this is point B. Now you see that for the equilibrium of part AB, there must be equal and opposite reactions acting at point B. For equal and opposite, there must be RB, which is also 4 units over here in opposite direction to RA, and there must be a horizontal reaction at B to counter the horizontal reaction at A. And the units must be same, right? It must be also 4 tons. Now you see that A cannot take any moment. The moment over here should be 0. Why? Because it was hinged portion. A is hinged over here. So A cannot take any moment. But at B, there is a moment because of, there is a bending moment because of horizontal reaction at A. This horizontal reaction at A is trying to rotate the beam in the anti-clockwise direction about point B, right? This HA is trying to rotate the beam in the anti-clockwise direction about point B. So, but this, because of the stability of the beam, it is not going to rotate anywhere. So there must act any counter moment at point B, right? So we are going to form this moment. Moment at B must be equals to this 4 into the distance between, this is 4 units, right? This is the distance between AB. So it is 4. So we are going to multiply this 4 and this 4 and apply a moment at B, which is nothing but 16 units. I'm not writing the units, but there will be a moment at B which is going to be in the clockwise direction to counter the moment which is produced by HA. And you know that since RA is acting in the same line of action at as point B, RA is not going to produce any moment at B. Right? Now, this moment MB is trying to rotate the beam like this. Is trying to rotate the beam like this, right? It's a beam and it will rotate like this. Something, it will turn like this. This portion will have tension and here it will be compression. So it's a convention, or you can say you can follow this convention to draw the bending moment. Like if you are drawing the bending moment for the tension part, you will take it negative. Okay, so what am I doing here? I'm drawing the bending moment for the outer portion of the beam, not the inner portion of the beam. Outer portion of the beam means here where tension is acting, and I'm taking tension as negative. So I'll be writing here as tension, I'm taking as negative. Okay, so this moment MB is trying to rotate the beam somewhat like this, which is producing tension on the outer surface of the beam. And for tension, I'll be taking the bending moment as negative. So what will I do? There is a moment of negative 16 over here, and there is no moment here, 0, because it is a hinge, and we know that for hinge there is the bending moment is 0 at the hinge. So it's done for now, and we'll join these 2 points with a straight line, and this is negative. So this is the concept of drawing the bending moment diagram for the vertical sections. Now let's go for the next portion of the beam, which is part BC. Let's first draw the part AB. So for part AB, what was going on? There was a reaction. This is HA, which was 4. This was RA, which was again 4. So to counter these two, I have drawn HB, which was 4, and RB in the opposite direction, which was again 4. Right? Now, as previously explained, there was a clockwise moment, MB, of 16 units. Now we have to analyze BC. So for BC, this is point B and this is point C. I'll just draw the equal and opposite forces and moments as here. Why so? Because point B is not moving anywhere. It is a rigid frame. It is not moving anywhere. So if HB is acting in the left hand side, there must be a counter HB which must act in the right hand direction, right? If RB is in the downward direction for part AB, there must be a opposite RB reaction in the upward direction, and with the same force, equal and opposite forces. Since there is a moment in the clockwise direction at point B in part AB, I'm drawing a moment which is anti-clockwise in direction, MB, which is opposite direction but of same magnitude, anti-clockwise direction. This was for part AB. It was in clockwise direction, so the moment is acting in the anti-clockwise direction for part BC. Now at point C, no forces are acting, so we have to balance the point C as well, and I'll balance it according to point B of part BC. So there is a HB force acting in the right hand direction, so there will be a counter HC force of same magnitude in opposite direction over here, and there is another RC reaction which will be of 4 units in the opposite direction but equal magnitude because part BC is stable, right? Now there is a moment at point B, but is there any moment at point C? No, there is no moment at point C. Why? Because it is an internal hinge and it cannot take any moment. Now it's time to draw the bending moment diagram for this one. So there is a moment MB of 16 units which is trying to rotate the beam like this, which is trying to make the beam in the hogging direction. Let me just enlarge this. A beam should be must have some dimensions, right? It cannot be a straight thin line. It is having certain dimensions. So I am drawing the bending moment diagram for this portion of the beam which is in tension, and I am taking tension as negative. So I'm drawing the bending moment diagram for the outer portion of the beam. If you want, you can draw the bending moment diagram for the inner portion of the beam as well. If you want to draw the bending moment diagram, you can draw the bending moment diagram for the compression side as well, but you must specify that you are drawing the bending moment diagram for the inner portion of the beam and what sign convention you are using. Like for tension side, I am using it as negative. The bending moment is negative for tension. This is the sign convention which I am taking. So there is a bending moment of 16 units over here, but 0 units over here at point C, because C is a internal hinge and it cannot take any moment. So this will be my bending moment diagram. And it will be negative because I am drawing it for the tension side. I hope this is clear up till now. Let's move forward and we'll be analyzing part CE of the beam. For part CE, let's draw BC first, okay? Let's not confuse you. Let's draw the BC first. So for BC, there was a HB acting in this direction, RB acting in the above direction, and there was anti-clockwise movement, okay? So there was HB acting in this direction, there was an RB acting in the upward direction, and there was an anti-clockwise movement of moment at B, which was of 16 units, right? If I'm not wrong. Yeah, correct. So to counter this, there was an reaction at C, which was also of 4 units, and there was a horizontal reaction at C, which was also of 4 units. Now we have to draw CE, right? So, and for CE, there is another load of 16 tons, which is acting at point D. Now, point C is at equilibrium. So, I am drawing these reactions at point C, which are equal and opposite to these reactions, right? So, there will be an RC acting in the upward direction. There must be a horizontal C which must act at the this direction, right hand direction, and the moment at C must be equals to 0 because it is a hinge. Now let's calculate everything for point E. Now for point E, there is 16-ton load acting in the downward direction. 4-ton load is acting in the upward direction. So there is a net 12-ton load acting in the downward direction. So to counter that, there must be a load of 12 ton acting on the upward direction at point E. So at point E, it should be 12 tons at point E, right? Now, there is no horizontal force anywhere else. So there must be a counter horizontal force, which it is horizontal E, and it must be of 4 units. Let's calculate the moment at point E. At point C, there is no moment, but reaction at C is generating a moment at E, right? And also this 16-ton load is generating a moment at E. So let's calculate those moments first. Let me just take the clockwise moment as positive. So 4 is trying to rotate the beam in the clockwise direction. 4 into what is the distance between C and E? It is 4 units. So 4 into 4. This is clockwise. Now minus 16 is trying to rotate the beam in the anti-clockwise direction. Into 2 is how much? 16 minus 16 twos is 32. So it is 6 minus 32 units. So there is a net anti-clockwise moment of 16 units at point E. So to counter that moment, there must be a clockwise moment acting at point E. So I'll draw a clockwise moment which will act at point E and must have the magnitude of 16 units. Now this portion is done. Let's draw the bending moment diagram. So let's take a point X from here. So what will be the moment at this point if I analyze the beam from the left hand side? So it will be RC into RC is how much? 4 into this distance is 2, right? This distance is 2 given in the question. 2 plus X. 2 plus X. And this is trying to form a sagging moment. So sagging moment on the top of the beam. So I am taking it as positive. But 16 ton is trying to rotate the point. 16 ton, mind it, 16 ton is trying to rotate it like this, right? Here somewhere 16 ton is acting and it is trying to rotate the point X like this. So it will be hogging. So let me write it 16x. At certain point, it is going to be 0, right? So let me equate it with 0. So 4 2s are 8 and plus 4x minus 16x must be equals to 0. Now 8 minus 12x must be equals to 0. This implies x is how much? X is 12 by 8. 3 by 2, that is 1.5. 1.5 meters from point D. This is 1.5 meters from point D, right? So at 1.5 meters from point D, the bending moment will be 0. So this is point C, this is point E. At point C, there is no bending moment. Now, the bending moment will start increasing as I move from point C to D. So from point C to D, it is continuously increasing. After D, it will start decreasing, and at 1.5 meters from D, I hope this is clear, at 1.5 meters from D, it will be 0. And at E, there is a moment of 16 units which is trying to rotate the beam in the hogging direction. If you see the beam from the right hand side like this, so this is trying to rotate the beam in the hogging direction, so this will be negative and the unit will be 16 units, right? It will be minus 16. Minus 16. And at point D, how much will be the moment? At point D, the moment will be 4 into 2, it is 8 units. So 8 will be positive and this is negative. Positive means there is a compression on the top fiber, right? And negative means there is a tension on the top fiber. Let's move ahead. Now we are going to analyze part EF. For part EF, let me just first draw part CE. There was a clockwise moment of 16 units acting here. There was a 4 unit like this, 4 unit like this. Now to counter that, there was this is horizontal E of 4 units, and there was a this 16 unit like this, RE of 12 units, right? Now we are going to solve for EF. Now since E is a stable point, there is a moment of clockwise direction over here. There must be a counter moment acting in the anti-clockwise direction in the part EF of the beam. So there is a counter moment of 16 units. Now there was a reaction, horizontal reaction from right to left. So there is another reaction HE, which is from left to right of 4 units. Now opposite to RE, there must be a reaction at E, which is again 12 units but opposite in direction. I hope this is clear. On the basis of these points, I'm going to draw a reaction at F, which is again 12 units in the upward direction. Now there will be a horizontal reaction HF of 4 units in this direction, and there will be no moment as point F is hinged. Now if you look carefully, this 12 in the upward direction and this HF in the from the right to left direction, it is same as the reactions which we found in the step number 1. Let me just show you. Look carefully. This RF was 12 units and HF was 4 units, which we got from this step, right? This was the same thing. I just wanted to show it to you. Now, once we got this, moment at E is trying to rotate the beam somewhat like this, right? So there is a tension on the outer edge. This is tension side. This is compression side. So as I'm taking tension as negative, so I will be drawing something 16 units over here, and there will be no moment over here. So I'll connect it simply with a straight line, and there will be a negative sign. Now we have analyzed each and every part of the frame. What we will do, we will draw the final bending moment diagram. Let's do that. Let's start with part AB. As you can see that for part AB, there was a bending moment of negative sign. That means the outer portion of the beam was experiencing a tension. So I'll draw the same diagram over there. So there is a 16 units over here. We'll join it with a straight line. Pardon me, because I cannot draw a straight line with a free hand, but this is a straight line and this is a negative sign. Let's check for part BC. So this was the bending moment diagram for part BC. It was again 16 units over here. At point C, there was no moment. So there is a 16 units over here. For point C, there was no moment. So again negative, and this is 16 units over here. Let's check for portion CE. So for portion CE, the bending moment initially increased from point C till point D up to 8 units. So from point C till point E, it increased by 8 units. Now from point D, it went on decreasing, touching a zero mark at a distance of, it was 1.5 meter, right? 1.5 meter from D. And at point E, it was a hogging moment, a negative 16. So you must write plus sign over here and minus sign over here. Alternatively, we can also draw like this, with a negative sign over here. Both are correct. So since I am drawing for the outer region of the frame, so what will I do? I prefer to draw it like this only. I prefer to draw it like this, which means for the outer portion of the frame, there is a positive sign. That means there is a compression on the outer portion, and after that there is a tension. After, and this was 1.5 meter from D, and this was C to D was 2 meters. So in total it is 3.5 meters. So you should mark 3.5 meters over here. So there are various ways of drawing the bending moment diagram. And lastly, we have to draw the part EF. EF is 16 units over here for point E. This was E, and for F it was 0, right? So E it was 16 units and F it was 0. So this is the final bending moment diagram. Now students, let me tell you a few more things about this bending moment diagram. There are various ways of drawing the bending moment diagram. In various books you will find different diagrams, so don't get confused that this is wrong, that one is correct. In various books you will find different things. Like, I can tell you, for the part CE, especially I want to highlight this part CE. I have drawn like this. You might find somewhere like this as well, because we are drawing we are drawing negative portion on the top of the frame, and this is positive. So somewhere you can find it like this as well for part CE. Somewhere you will find it like this or like this as well. Or as I have drawn like this as well. So there are various formats of drawing the bending moment diagram. Don't get confused. The convention which I am using is that I am drawing the bending moment diagram for the outer portion of the frame. You can also draw it for the inner face. Have any doubts? Please post your doubts in the comment section. I'll try to go through your doubts. Meanwhile, if you like the lesson, don't forget to hit the like button, subscribe, and follow me for more. Thank you and have a nice day.